and for which block will topple. So line of action of mg should pass through the contact point P that I explained earlier. Next is what is condition for which block will slide. So for sliding, theta should be greater than tan inverse of mu. Next is what is condition for which block will not slide. So theta should be less than tan inverse of mu. Next here is a question, a cuboid is given. A mass m moving with a speed v collides with it and coefficient of friction is mu. Then we need to find velocity of block just after collision if collision is perfectly elastic. So we assume that they just collides and the time duration is very less. So there is no role of friction over there. So if we calculate using this, we can say center of mass will be having velocity v. Although just after the impact, friction will come to the role and it will stop the block from moving. So we assume that. Next is find velocity of block just after collision if collision is perfectly inelastic. So for perfectly inelastic collision, momentum will be conserved. So both will stick together. So using conservation of momentum, we can say that speed of center of mass will be v by 2. Next is find conditions for toppling if collision is perfectly elastic. So when it will strike, then the entire system will rotate about this hinge point with an angular speed omega. And for toppling, the center of mass should be passed through this point P. So the entire body will be in pure rotational motion about this point P. So half I omega square, which is a rotational kinetic energy, should be able to cross the barrier of potential energy, which is mg into root 2a minus a by 2. I here will be ma square by 6 plus ma square by 2. So from here we can calculate omega, and using conservation of angular momentum we can find omega in terms of v. So this is the condition. If the collision is perfectly elastic, that means this mass will also be considered. So here again the condition is same, and we have taken the increase in potential energy of this mass as mg into root 2a minus a, and I as initial moment of inertia of the cuboid plus moment of inertia of this block about this axis. So the distance is root 2a, so the moment of inertia is m into root 2a whole square, which is 2ma square. So in this way we can find the conditions. So you have seen that these are the optimization worksheets, and they are developed with the vision that you actually prepare rather than acting to prepare. Because when we study, then the goal of study is to form certain neural patterns or to develop certain classified information which you can apply in different real life situations to test your application of the concepts. So study is effective only when you have decoded certain neural patterns and learn how to use this as and when needed. So if you have any doubts, you can ask in the doubt section, in the comment section. Thank you and have a nice day.